Dr. K. Paranivelu, Professor at the Center for Environmental Studies and Director of Center for Climate Change and Disaster Management, Anna University, Chennai. He obtained his PhD degree from Indian Institute of Technology, Madras, Chennai. He worked as project officer for a brief period at IIT Madras and moved on to the Center for Environmental Studies, Anna University in 1992. He was a visiting professor at Chungam National University, South Korea during 2007. He has been teaching courses on environmental chemistry, environmental pollution control, and instrumental methods of analysis since last 27 years. He has guided 75 students for ME and MSc, 4 MPhil, 2 MS, and 15 PhDs. He has published 135 papers in journals and 90 in conference and symposiums. He has received several awards in national and international levels.
Welcome to the lecture series on environmental chemistry. We are discussing about aquatic chemistry and water pollution. In this lecture, we are going to discuss about water and wastewater treatment. In the previous class also we discussed about various water quality parameters and the significance, the standard value, including the organic parameters like COD, BOD. Coming to this water treatment, what are the objectives of this water treatment that we should first know? And look at the water quality, especially from whether it comes from surface sources or groundwater that we have to pay, that is going to be used for drinking purposes or other purposes. So, surface sources can fluctuate with the weather and other activities in watershed, both human and natural, that may influence the quality of the water of the surface water. As a result, what happens is users of untreated water can be exposed to pathogens that is actually present in the turbidity of the surface water. Also, it is important to evaluate the quality of the water source and the water treatment processes to ensure the high quality safe drinking water for everyone. So, the main objective of water treatment is to remove the different impurities in the raw water to render the water safe for domestic as well as fit for industrial applications. So, the water objective treatment objectives varies whether it is for domestic drinking purpose or for industrial applications. Accordingly, the treatment is decided. When compared to domestic drinking purpose, industrial water quality requirement is very stringent, especially it is used for boiling or cooling purposes. And generally water is treated by a process or operations called unit operation and processes involving the following aspects that makes the water fit for both drinking as well as industrial applications. If you see the unit operations, mainly it consisting of physical treatment, that is unit operations involve bringing a physical change, and this is normally known as primary treatment. And the unit operation is any part of the potentially multiple step process which can be considered to have a single function. That is, examples of unit operations include simple filtration, mixing, sedimentation, etc. Comes under the unit operation in water treatment processes. And coming to the unit operations involved, it is mainly consisting of chemical treatment, whereas in the unit operation physical process, whereas in the unit processes mainly chemical or biochemical things. Especially water treatment, it is a chemical process like oxidation, hydrolysis, disinfection, etc. So, the unit process include all the treatment methods in which the removal of contaminants is brought out by chemical or biological reaction, and it is considered as a secondary treatment, whereas in the unit operation mainly as a primary treatment, the unit process or secondary treatment. So, combination of physical and chemical methods are employed in removing the impurities present in water. Water treatment, the process of removing all the type of impurities from water and making it fit for domestic or industrial purposes, as mentioned before, the objective of the treatment. So, the treatment of water can be classified into two categories as the objective. One is purification for domestic use, the other one is treatment for specialized industrial application, where still the norms are very, very stringent. And the treatment of water for industrial use, we have to consider numerous factors, and we have to take into account considering in designing and operating an industrial treatment facility. These include the following things. One is the water requirement and quantity and quality of available water sources, successive uses for applications requiring progressively lower quality, water recycle, discharge standards after use. So, all these factors we have to consider when we design the water for industrial use. And generally the surface water that is coming from a lake or river, if it is used for domestic drinking purpose, this is the following treatment usually given. It consisting of the following steps. One is screening, that is to remove the large floating material. With the help of screen, if you put it the entering point of the treatment plant, usually all the floating material, large suspended impurities will be removed from the screen. So, after this, sometimes pre-chlorination is done using chlorine. Pre-chlorination is done to make the coagulation or flocculation process more effective. Sometimes without pre-chlorination it is not very effective. So, the pre-chlorination is done to make the following coagulation and flocculation is very, very effective. In this coagulation flocculation process, coagulation is carried out using aluminum hydroxide salt, that is alum dissolved in water, that is actually undergoes hydrolysis, forms the aluminum hydroxide, and it is positively charged colloidal particle. If you add this alum salt, aluminum hydroxide salt into the water, usually the impurities present in surface water are negatively charged colloidal particles. So, due to the charge neutralization, the repulsive forces are removed. So, charge neutralization is taking place by this positively charged aluminum hydroxide salt, but the impurities actually present in water. There is a neutralization of the charge and coalescence is taking place. Ultimately, the smaller particles of coagulate particles forms a bigger unit, gets agglomerated and ultimately settle into the bottom, and that is sedimented out. And sometime flocculation coagulation aid may be added, like activated silica to make this process effective. Once everything is, the larger particles are sedimented out, that is settled out, and then pass through a filtration unit, normally sand filter, and the salt filter, any residual suspended particles are there, that will be removed with this retained on this filter bed. Ultimately, the water free from all the impurities, the original colloidal negatively charged and the residual impurities from this coagulation process, everything is filtered out and clear liquid will it. And this clear water is disinfected usually by chlorine, or sometimes ozone or UV also used for disinfection purposes. Okay. So, make this water free from all pathogenic organism. Okay. So, this is a various steps actually involved in water treatment for using surface water like a lake water or river water, and this is also shown here in a sequential way in this diagram. You can see here the surface water from the water supply area comes here, and there is a screen that will remove all the larger particle. Then it goes to the rapid mix with the alum, and then flocculation takes place, slow mix, and then moves to the sedimentation basin in which the sludge, coagulated sludge will be removed here, and the free water from main sludge will goes here, and that is actually then passed through a sun filtration, normally rapid sun filter, and goes here. Any residual impurities of suspended impurities present, that comes out and it is disinfected and the water is fit for distribution, stored, and it is distributed for public for consumption. So, this is a general treatment of water. You can see here, first removing the floating material, then hydrolysis, it is a unit operation, unit processes here, coagulation, sedimentation, again unit operation, and then disinfection, unit process. Okay. Combination of both unit operations and processes are taking place. Whereas, if it is a groundwater, it actually varies. The treatment process varies and depends on what is the impurities present in it. And the groundwater, generally the hardness nowadays is increasing. Okay. Based on the hardness value, it is classified into 4 types, that is soft water containing hardness below 75 milligram per liter as calcium carbonate, moderately hard between 75 to 100, hard water 100 to 300, and very hard water above 300, which is unfit for domestic purposes and as well as industrial purposes. And the hardness, if you look at it, it is mainly caused by cationic divalent ions like calcium, magnesium predominantly, and sometimes ferrous and manganese oxides also will be there. Okay. But most of the water contains calcium and magnesium ions. So, total hardness is a sum of calcium and magnesium values of this, and usually it is expressed as calcium carbonate equivalents. So, if the water is hard, water softening is required, especially for industrial operation. The water used in cooling purposes and boiler operation should be very, very soft. Okay. So, the hardness causing ions like calcium, magnesium to be removed, otherwise they will get deposited as calcium oxide or calcium carbonate, magnesium oxide, etc., and waste the heat energy in the boilers. And coming to hardness again, there are 2 types of hardness. One is called temporary hardness, that is actually associated with the carbonate of calcium and magnesium. The other one is permanent hardness or non-carbonate hardness, and here usually the calcium and magnesium ions will be bind to ions like chloride and sulfate. And depending on this, whether it is permanent or temporary, the hardness removal methods also varies. The method of removing hardness for temporary, simple boiling may bring out the removal of hardness. Here the water from groundwater, usually the ions will be present as a calcium bicarbonate. The hardness is called by water soluble calcium bicarbonate. If you heat it, what happens is the bicarbonate ion will undergo decomposition, evolving carbon dioxide. Okay. Ultimately, the water soluble calcium bicarbonate, due to the heating, okay, actually it is converted into calcium carbonate. This calcium carbonate is insoluble. This is what creating problem in boilers and all. During application of heat, it undergoes bicarbonate, undergoes decomposition, get deposited as calcium carbonate. The other method is of removing temporary hardness is adding lime addition to calcium bicarbonate. If you add calcium carbonate, it is actually converted into calcium carbonate. Here again it is insoluble, gets out the system, water system, and removed as a insoluble calcium carbonate. Okay. So, the water softening, if it is a temporary hardness, it can be removed by simple boiling or addition of lime. Whereas, suppose the water is associated with permanent hardness ions like chloride and sulfate, the removal is somewhat difficult. Simple addition of lime may not bring out the desirable hardness removal, and a combination of lime and soda ash addition, that is sodium carbonate addition, is required to remove this permanent causing ions impurities. So, neutral first what happens is in this process, addition of lime and soda ash, neutralization of free carbonic acid is there. If any free carbon dioxide is there, the addition of lime, it gets converted into calcium carbonate as an insoluble precipitate. And precipitation of calcium hardness ions like due to calcium also takes place, that is calcium ion with a bicarbonate. If you add a lime, it is again gets converted into insoluble calcium carbonate ion. and suppose the hardness causing ion, calcium hardness, is from due to magnesium ion, then what happens is the added magnesium ion with the bicarbonate, if you add calcium hydroxide, it gets converted into magnesium carbonate and calcium carbonate. And this magnesium carbonate, in presence of addition of calcium hydroxide, gets converted into magnesium hydroxide at a insoluble precipitate, and calcium carbonate both gets removed. So, free carbon dioxide, calcium and magnesium hardness due to carbonate hardness is removed in this way. And suppose removal of non-carbonate hardness, that is the calcium, if it is attached to calcium, the non-carbonate hardness, calcium sulphate, by the addition of sodium carbonate, what happens is it is removed as calcium carbonate impurity, and chloride again removed as a calcium carbonate. So, this sodium carbonate brings in the conversion of these ions into insoluble calcium carbonate. Suppose the non-carbonate hardness causing ion, magnesium is associated with chloride and sulphate, addition of calcium hydroxide converts it into magnesium hydroxide again, and addition of calcium ions, sodium carbonate, it gets converted. So, here how this non-carbonate hardness causing ion like calcium and magnesium converted into insoluble impurities here. In case of non-carbonate hardness causing ions, little more addition of soda ash, that is sodium carbonate, is required to make it completely removed as a insoluble components. Another process again mainly used in industrial process is demineralization. That is, here not only hardness causing ion, completely removal of all cationic and anionic impurities is possible. In addition to calcium magnesium ions, anionic impurities associated with the chloride and sulphate also removed by this demineralization. In this process, what is done is resin are used, both employing cationic resins in the form of H plus, useful to remove the cationic exchange cationic impurities present in water, and anionic resins normally employed in the hydroxide form, again useful to remove the impurities like chloride and sulphate if they are present in water with this anionic exchange resins. So, ion exchange resins in cationic form and anionic form is employed to remove this all the anionic and cationic impurities present in water. After use, these ion has to be regenerated, because the capacity is limited. With the acid and the alkali, these resins can be regenerated. For example, cationic resins can be regenerated with the acid. All the calcium, magnesium, sodium ions will be removed with replaced with the H plus ion at a higher concentration. Similarly, the hydroxide, sodium hydroxide is used. It is again all this chloride, sulphate ions will be removed in the adsorbed thing, and it can be regenerated. So, after applications, removing this, it may lose its capacity. Once it reaches its capacity, it has to be regenerated with the acid and alkali. And these demineralization not generally used for domestic things, mostly it is used for industrial applications. But one problem is the regenerant liquid disposal is a problem. Care must be taken to dispose it very properly, because they may contain concentrated ions of anionic and cationic impurities. Defluoridation is another things, because most of the groundwater in India is contaminated with fluoride ions. So, the groundwater used for domestic drinking purpose may create all this skeletal fluorosis and dental fluorosis disease. So, this should be prevented, and the concentration should be brought below 1.5 ppm. So, that is the main reasons dental and skeletal fluorosis above 1.5 in groundwater. And suppose no fluoride in water, sometimes it is possible. Fluoride is also required to prevent dental caries, etc., to prevent dental decay. Sometimes fluoride is added to water with about 1 ppm level. So, that is also good. In fact, fluoride in water is a dual importance. Absence of fluoride as well as high amount of fluoride is detrimental to health, and around 1 to 1.5 is the ideal of a fluoride concentration in drinking water. But in India, the main problem is many of the groundwater is above 1.5 ppm. So, removal of fluoride, that is a defluoridation, is very, very important. And here the defluoridation process, water passes through a defluoridation media such as tricalcium phosphate, bone char again containing calcium phosphate, bone meal and activated alumina, all used for removal of fluoride, because in these adsorbent both calcium and aluminum ions present in this tricalcium phosphate, bone char, bone meal, etc. calcium is present, whereas in the activated alumina actually aluminum ion is present. Fluoride is having affinity to react with this calcium aluminum, that is these ions are called type A ions, as we discussed in the before lecture series. See, this fluoride will like to bind with the calcium and aluminum ions. So, these aluminum and calcium containing materials are used as an adsorbent for defluoridation purposes. And one of the popular defluoridation technique is Nalgonda technique, that is addition of aluminum and lime. Aluminum and lime is added, or sodium aluminate is added to water, and this technique is called, developed by Neary, and in the place Andhra Pradesh, Nalgonda place this was tested. So, this is popularly called Nalgonda technique, developed by Neary CSIR organization, where fluoride is binded with aluminum and calcium, completely removed, and effective defluoridation technique. Another method used for commonly to remove all the impurities nowadays at almost all home, one of the common technique is RO, that is reverse osmosis based membrane technology is used for water purification. It uses a semi permeable membrane to remove ions, molecules and larger particle from water. What we discussed, defluoridation, hardness, it is all specialized focusing on this one particular thing, but RO is a collectively to remove all the impurities present. Here an applied pressure is used to overcome the osmotic pressure, so that it can remove many type of dissolved and suspended species from water, including bacteria, and is used both in industrial process and the production of potable water for domestic purposes. So, the result is that the solute is retained on the pressurized side of the membrane, and the pure water molecule is allowed to pass through the other side. So, only always water will pass through the membrane, solute will be retained, that is normally becomes a reject, and the disposal of the reject is one of the major problem, and especially for whenever RO is used for industrial application like tannery and textile industries. Nowadays pollution control boards are insisting for zero liquid discharge. So, most of the companies they go for this RO based treatment of the industrial effluent. Ultimately RO is used to recover the water, but the reject is a problem, and the disposal is a huge quantity containing water, highly water soluble salts. And the schematic diagram of osmosis and reverse osmosis is shown here, and this is applied pressure. If you apply pressure, this is a semi permeable membrane which is separate, and if you apply pressure, the solid molecules will be retained, pure water will pass through, you will get a fresh water that is fit for domestic purpose. All the impurities are retained here. The disposal is a concentrate is a problem, and this is a, when you compare with the osmosis, okay, water solvent will move to the concentrated solution site. So, this is a normal one, normal osmosis, whereas reverse osmosis is different, in which you have to apply water pressure to this side where salt impurities are present, and fresh water will move to this. So, wastewater, coming to wastewater, we use water for domestic purposes and industrial purposes, all this. Ultimately we end up with wastewater that also has to be managed properly to protect our environment. coming to wastewater, especially domestic wastewater, it consisting of 3 stages of wastewater treatment process. Okay. And these processes are normally known as primary, secondary and tertiary treatment. Okay. The primary, it is consisting of mainly unit operation, and this large suspended impurities will be removed in this primary treatment. Coming to the secondary treatment, this is actually the main treatment for as far as wastewater treatment. There are 2 type of treatment, and this one is anaerobic or aerobic treatment. The secondary mainly aim to remove the organic impurities and the nutrients here, and another one is a tertiary treatment. This is an advanced treatment in which the secondary treated effluent is treated for the if there is a need for reuse purpose. Okay. And especially in the context of climate change, now water availability is a problem due to drought situation as well as extreme rainfall. Water saving potential is minimized. So, we have to look for the treated sewage for industrial and other applications. So, the tertiary treatments are in handy. Now, we are going to see how this secondary treatment system works here. Anaerobic and aerobic systems are both forms are biological treatment that use microorganisms to break down and remove organic contaminants as well as nutrients from wastewater like phosphorus and nitrogen. Phosphate and nitrate also getting treated here in this anaerobic and aerobic treatment system. So, organic matter are made to undergo degradation in presence of microorganism. That is the concept of this biological treatment. But the key difference between these anaerobic and aerobic process is that in the aerobic system require oxygen to bring out the desirable degradation, as in the case of BOD determination, while anaerobic system do not require oxygen, and in fact it is carried out without oxygen. And if you look at the nature of when to apply aerobic and when to apply anaerobic treatment process, and aerobic treatment system are best suited for waste stream with a relatively low BOD and COD ratio, and are used for removal of nitrogen and phosphorus. Whenever the organic matter content is low with respect to COD or BOD, then we can go for aerobic treatment. On the other hand, anaerobic system are typically used for treatment of waste stream with high concentration of organic contaminant. Okay. So, in the biological treatment, the thumb rule, whenever we have low values of organic matter, namely COD and BOD, we can select aerobic treatment, provide oxygen that will convert all the organic matter into carbon dioxide and water. Whereas, in the case of anaerobic, where the organic matter is also high, organism will be present, but do not provide any oxygen, what happens is the organic matter is converted into series of steps to ultimately to methane, which is a bioenergy that can be used for various applications for energy burning. So, the main difference between aerobic and anaerobic depends on what is the organic matter content, and again whether it should be easily biodegradable. Usually the BOD COD ratio is the thumb rule. If it is generally high above 0.3 or 0.4, generally it fits for biological treatment. Depending on the organic content of COD BOD values, you select low values. Domestic water usually contains about 300 ppm, then it is fit for aerobic. Industrial organic waste like distillery and other things, where the concentration is very high, you can go for anaerobic treatment to get methane and energy. So, this is a schematic diagram of the aerobic treatment process as shown here. The effluent is seriously treated in each basin, but this aerobic tank in which actual degradation is taking place, very important. Cleared water will go here, the suspended activated sludge will be returned here, and that is used for again energy production. In the case of anaerobic, there is no oxygen is there, slowly the organic matter will be converted into volatile fatty acid things in presence of organism, okay, and ultimately it will be, with the help of acetogenesis, it will be converted to acetic acid and finally into methane through methanogenous bacteria present in the anaerobic process. So, our organic matter through a series of things, acetic acid, and ultimately to methane, it is converted, which is a bioenergy. Again, we have wastewater treatment standard for various parameters, like depending on where we are going to discharge this into public sewer or land for irrigation or into coastal environment. Accordingly, we have 3 levels, and you can see here, especially in the BOD COD values are very important. Okay. We have to look at the COD values and BOD. These are the 2 things mainly meant for organic industrial pollution, and it has to meet, the COD value is 250 milligram per liter. To sum up, water is becoming a precious and scarce commodity nowadays, especially from the angle of climate change. So, the water has to be used judiciously. Even now started using sea water for our domestic purposes. Desalination of brackish water and salty water is even in India it is catching up. That is going to be the future to meet our water requirement. Not only this, even recycling of wastewater is also important. With the proper treatment, the treated sewage can be used for various industrial applications. This is also on the rise. So, reuse of wastewater and segregation of grey water is also going to be the future to meet our water challenges. Thank you.